Children, welcome back to CK classes. Myself is CK. So in today's session, we are going to learn about something interesting and important topic comes under a 10th standard mathematics. So before I could proceed with the lesson name, so let's have some basics regarding to what in that lesson. So just I'm not revealing the lesson name. So later you will come to know which lesson you are going to learn in today's session. So everything starts with a general plane. So in my hand just have a small plane because it's a rectangular, a smooth surface considers a plane. Suppose when we draw two perpendicular lines on a given plane, so it appears like this. So you can, as I say, I already drawn two perpendicular lines here. So if you notice clearly, you will observe the two perpendicular lines. So hope you are already getting ideas. So what are the topics you people are going to learn today? So these lines have special features with respect to the plane. So this was the idea was first generated by the René Descartes. So René Descartes was the guy behind this trick. So who is René Descartes? Often considered as a father of something. I'll tell you later. So now let's come to these cases. So let's understand the key factors associated with this plane when we draw two perpendicular lines. You can observe the horizontal line. I could name it as something. So I'll just use this one. So I can name it like this. That is X, O, X dash. On the other line, you can say name it as what? Y, O, Y dash. So the horizontal line X, O, X dash is considered as what? X axis. And Y, O, Y dash, the vertical line Y, O, Y dash is considered as the Y axis. So when we draw two perpendicular lines on a given plane, the system what you will get, we can call them as a Cartesian system, or you can say a rectangular coordinate system. So please make a point with us. When we draw two perpendicular lines on a given plane, so the generated plane is considered or called as a Cartesian plane or what? A rectangular coordinate system. So when we draw two perpendicular lines in a given plane, the entire plane is divided into four different rectangular boxes. Hope you all observe this one. This is box 1, the box 2, the box 3 and box 4. Each box is named as quadrants. So you already learnt it in your previous class, 9th standard or 8th standard. You have some bit basics about what the graphs. So I told us these four boxes are considered as a quadrant. So here, the first box is a positive box. You can say, you'll observe this plus and plus in this case. It's a positive box. So you can write some names like this. That is 1, 2, 3. That's positive 1, 2, 3 I'm writing. So in this comes to this one, the third box. So you can say you have written boxes or numbers in the what? Anti-clockwise direction. And the what? This opposite to the positive box will be a negative box. That is minus and minus. So that's what you can say here, the minus 1 and minus 2 and so on. So and the upper part, since the second box is not positive or negative box, here a combination of negative and positive, that is minus and plus. It's a reverse for this is plus and minus. The four boxes easy to memorize by using this rule. This is a positive box and negative box here, negative and positive and negative. So let me have some names here. So this 1, 2, 3 I have taken here, again still positive 1, 2, 3. The downward is still negative, minus 1 and minus 2 and so on. So this is considered as what? A Cartesian plane or rectangular coordinate system. So what should I do with this rectangular coordinate box or a Cartesian system, and what we are going to learn today? So with the help of this, the help of what? A Cartesian plane, the René Descartes as a plan to what? Solve different problems comes under algebra. So he is the first guy to relate algebra with geometry. So let me recall some of the concepts you already studied in 8th and 9th standard. Hope you all remember a linear equation. Okay, if you consider the linear equation. So you have drawn many graphs on linear equations in 8th as well as 9th. In 9th standard you learned about linear equations in 2 variables. In 8th standard you learned about what? Linear equations in 1 variable. In both the cases you have drawn graphs. Hope you all remember that. So when we plot a graph by using linear equations, we are going to get what? A straight line for this. So can you remember this? If you draw the straight line, that represents some linear equations. Suppose if we extend our knowledge, suppose we have a quadratic equation. So quadratic equation is a generated equation by using quadratic polynomial. The equations are the form of second degree equations, or equations of the forms of what? Ax square plus bx plus c. Okay, so that what that graph, also the graph obtained by quad equations will be something that's very easy to say, very nice to say. Let's say parabola. What is the parabola? I'll draw some of them. So see now, when we just draw a straight line, so it's a straight line, represents something called, it will give something, this line generated by using linear equations. Suppose if you draw a graph like this, so this graph is considered as a parabola. So parabola, it's a straight line. So I'm not writing properly, but remember that one is a straight line and parabola. So this, okay, this was the idea. Okay, so this is the word straight line is geometry. Also the parabola is geometry. Your lines are geometry. But you have generated these lines and parabolas by using algebra. So that's what you can connect them. The connective part is very important one. So I told who is the magician behind this trick. I told it's a René Descartes. He's the first guy to treat what algebra geometrically. He had connected the algebra with geometry. So now let's learn what we call this one. So we can consider this is something, a beautiful branch. So this branch is called as a coordinate geometry. So the lesson what we are going to learn today is a coordinate geometry. So sometimes it's called as analytical geometry, or sometimes you can use it as a Cartesian geometry, since René Descartes is a founder. Okay, so now what is coordinate geometry? So coordinate geometry is a branch of mathematics which treats algebra geometrically, which treats geometry algebraically. You can vice versa connection for this. So algebra, geometry, geometry, algebra, you're connected by a branch, is called what? A coordinate geometry. So in your previous classes, you have got many ideas about what? A coordinate geometry. Some of them just I'll recall them now. So you have already studied that locate a point on a Cartesian plane. So this was a basic, and this is a result. So you want to create what? A Cartesian plane by using, you have to draw the lines, but here the lines already drawn, so you have a beautiful what? Cartesian plane. The only what still you can do this one, you just highlight the lines. So just highlight it and make it what's a Cartesian plane. So still it's a Cartesian plane. With the help of this, you can do many things. And also this has wide varieties of applications. You can observe coordinate geometry in engineering, and what I can say seismology, in art cases, in many what? In physics. Okay, so in many areas it has applications. So one by one, so we are going to learn what about them in future class. So let's learn some key factors related to a Cartesian plane under a concept. So now I have drawn two perpendicular lines, just what I drawn already in the what page. So the point where two lines meets, or two perpendicular lines meets, we can call the point as origin. I can say. So the coordinates of origin. This is the word already heard about coordinates. So you can say x coordinate, y coordinates. So now if you have the coordinates at origin, the coordinates at origin will be a 0, 0. You can say coordinates of origin. So please make this key point. So often you might need this. The coordinates of origin will be 0, 0. Usually represent by using brackets, you could say 0, 0. So later on, as you know, that's a positive part. There's a positive part. can say 1, 2, 3, and as you know, it's also positive part. 1, 2, 3. As it's a negative part, it's minus 1, it's minus 2, it's minus 3. Since it's a negative part, it's minus 1, minus 2, and minus 3, and so on. So now, we already learnt about a plot, a point on a Cartesian plane. Suppose if I place a point on a Cartesian plane, imagine I placed a point here. When I placed a point on a Cartesian plane, you can represent, I can represent by the symbol something. You can name the point as certain P, and it creates two different distances, as you all know that is. The first distance will be x coordinate, and the second distance will be y coordinate. You already learnt about this one. So point can be represented by using P of x comma y, where x represents x coordinate and y represents y coordinate. So what is x and y coordinates? What are the other names you could use for x coordinate and y coordinate? And how do I recognize the distance? So I name the point as P here. So I should write the distances here. What the distance? So what are the distances from two different distances with respect to axis? So have two different axes. You know that this is something called x o x dash, and this one is y o y dash. So with respect to axis, so there will be a distance. Okay. So first one, I'll consider distance from y axis. It's a perpendicular distance from y axis. This distance is called as abscissa. So you already learnt it. So the perpendicular distance from y-axis to a given point is called as abscissa, or simply x coordinate to tell that. And also a perpendicular distance from y-axis. Okay, a perpendicular distance from x-axis to the given point is considered as ordinate. Or another name of ordinate is y coordinate. You can use this word often. We'll use the word x coordinate and what? Y coordinate. So we will not use abscissa and ordinate, but you should have idea about what is abscissa and what is ordinate else. So let's find, it's time to find what is abscissa of that point P. So now you just count it from perpendicular distance from y-axis to the given point. You can say here the 1 and 2. You can say the perpendicular distance from y-axis to given point is 2, and the perpendicular distance from x-axis to the given point is still 1, 2. So you can say the coordinates of the point P, when we plot that point on a first quadrant, so I'll get a coordinates as 2, 2. So that's what you have learned it about what locating a point on a Cartesian plane. So this was the basic. So you can say you must know about what abscissa, ordinate, or y coordinate, or x coordinate, and the distance from so not the distance, so that is how you recognize the distance from x axis and y axis and so on. So after this, so this was all of basics you already learned in 8th and 9th standard classes. So what we are going to learn in this year and in this what academic year. So now have some two different cases here. Suppose I will take this away. Suppose I'll mark two different points. So just one point, I'll just mark it on the first quadrant, and I'll just mark another point on the third quadrant. The question is, if I join them, so when I join them, it creates two different, it creates a distance. Okay, so it creates something called distances. Is there any possibility to find a distance between two distinct points on a Cartesian plane? So by using some strategy or some rule? Yes, there is a possibility. That's what we are learning. So and also if I just make another point with respect to the coordinate 3, so quadrant 3, if I join them, so example, what interesting thing I'm getting here, I got a beautiful triangle with respect to three different coordinates or three different points on three different areas in a Cartesian plane. So will I find area of this triangle by using some concept? Yes, there is. So that's what we are learning in the second concept comes under this covered lesson. So in brief, let me not what make you burden with what you are learning that and all. Just let me introduce the lesson. So what are the main objectives of this lesson? Number one, you can find distance between any two distinct points on a Cartesian plane by using a distance formula. The distance formula is the first concept, comes under a coordinate geometry. The second one is something called a section formula. What is section? Section means make it divide. Suppose you have a straight line. You are divide that line with respect to some ratio. When you know the ratio on coordinates of two different points, will I find which point, the point where you divided? You can get the coordinates of that point by using section formula. The second concept is section formula. The third concept, so comes under this one is you have a triangle. So in that triangle, you can find area of a triangle. You can